Hi guys, this is going to be the beginning of our series on twin gestations. We're going to start by reviewing some very basic concepts that I think are important to understanding twin physiology and the complications that affect multigestational pregnancies. And so let's get started. So very basic definitions. When we refer to the chorion, that is referring to the number of placentas. And so a dichorionic pregnancy has 2 placentas. Monochorionic pregnancies have 1 placenta. Diamniotic has 2 amniotic sacs. Monoamniotic has 1. And so when you hear people talking about di pregnancies, we're talking about the 2 placentas and the 2 amniotic sacs. And understanding that is important when you think about why certain multigestational pregnancies are higher risk than others and potential complications that we will review on a later slide deck. All right, to review some very basic embryology, you start with, we all know this, the 2-cell stage, and you get cleavage to create 4 cells, and then you get cleavage again to create 8 cells, etc., etc., etc. The 16-cell stage is also known as the morula, and then that morula becomes a blastocyst. You will kind of see this when you rotate through REI, but the general anatomy of the blastocyst, you have the inner cell mass, you have the cavity, and you have the trophoblastic cells. We're going to have a dedicated kind of series on embryology, so I'm not going to go into much detail right now. And so this is just looking at the anatomy of the fetus at 10 days and then at 12 days. And so here, just to point out very obvious stuff, you have endometrial glands, spiral arteries. This is your amnion. This is the yolk sac. These are your cytotrophoblastic cells. These are your syncytial trophoblastic cells. And this is the lacunar network that allows for exchange of gases between the fetus and mom. And so maternal blood is kind of flowing through this network. And so to go into basic definitions, what is dizygotic versus monozygotic? So very simply, dizygotic results from the fertilization of 2 separate ova. So this yields fraternal twins or dizygotic twins. From a genetic perspective, they're like any other pair of siblings. This is in contrast to monozygotic twins that are referred otherwise as identical twins. They have the same, and I say that in air quotes, genetic heritage. However, we know that even monozygotic twins are not exactly alike in every way. And that's because there's an unequal sharing of protoplasmic material, and that could lead to subtle differences. This is kind of a cute example that exemplifies that. So it was a study that showed 926 monozygotic twins looking at the prevalence of congenital heart defects. It was 12 times greater than the general population rate in this particular cohort, but 68%, so more than half of the infants had a normal siblings. So that's showing you there's some type of unequal sharing of predisposition to certain syndromes that probably require complex patterns of inheritance. So this is the money. This is what you need to know for Creog. So I would spend some time. If you don't spend time on any other part of this, this is where you should focus. So how do you get different type of twins? This is where the Creog question will ask you. When you split at 2 days versus splitting between 3 to 8 days versus splitting between 9 to 12 days versus splitting at greater than 12 or 13 days. And so if you just think about, let's take dizygous pregnancies first. So you have egg, sperm, you have another egg, another sperm, and that will create a dichorionic, diamniotic pregnancy. Right, simple. And that represents about 70% of twins, excuse me. The other 30% of twins are monozygous, okay? So you have one egg, one sperm, and then they're splitting at different points of time. If you split early, so it says here in the first 2 days, some texts say in the first 72 hours, whatever. Early splitting, well, you have to remember, you get a dichorionic, diamniotic, okay? They're splitting, and you're getting the most differences between the two pregnancies. If you're splitting a little bit later, so 3 to 8 days, or some people say 4 to 8 days, then you get a monochorionic, diamniotic pregnancy. So they're sharing a placenta, 2 separate sacs, okay? If you are splitting even later than that, so somewhere between 9 to, some texts say 12 days, I've seen 13, then you get a monochorionic, monoamniotic. This represents about 1% of twins. These twins, just kind of note, we'll talk about it a little later, have the highest risk of complications, except for conjoined twins, which are rare. So we're not going to spend too much time focusing on that. But that's if you get splitting after 12 days. And so think, this is like the take-home point. Think 2 to 3 days, 4 to 8 days, 9 to 12 days. And that produces your 3 different types of twin: dichorionic, monochorionic, monochorionic, diamniotic, and then your monochorionic, monoamniotic.